Welcome chemists to another episode of Bale's Chemistry. Today we're looking at a new topic 1.11, electropotentials and electrochemical cells. You're going to find this on paper 1 of your A-level chemistry exams. Whilst you're here, don't forget to subscribe to make sure you get all the new videos on this topic and lots more. And let's go for today's episode. So the first thing we're going to do is we're going to remind ourselves about redox. So we've got reduction is the gain of electrons, and here we're showing it with X plus an electron makes X minus. And we've got oxidation, and oxidation is the loss of electrons, and here we've got X losing an electron to become X plus an electron there. So if you can find that difficult to remember, we've always got the oil rig mnemonic, which we can use to help us remember that oxidation is loss, reduction is gain. Now, if you remember back to year 12, we also talked about half equations, and we can get half equations where they show the oxidation process and where they show the reduction process. Remember that we can combine those half equations together where we balance up the number of electrons, we cancel those electrons out from both sides, and we have one full equation for the redox process taking place. So what we're interested in today is what happens when we put metals into the solutions of their own ions. Now they can do one of two things when we do this. They can either oxidize their atoms and lose electrons to form ions, or they can reduce their ions, gaining electrons to make atoms. We're going to look at how these two processes can happen together to make an electrochemical cell. So this is an electrochemical cell. It's a little bit similar to what you might have seen at year 11 when we looked at electrolysis. We have an anode and a cathode, and at the anode we have oxidation reactions taking place. That means that the anode is a negative because as the oxidation takes place, the atoms lose electrons and provide those electrons up into the circuit. Now at the cathode side we have a reduction reactions taking place. These are positive because they take in the electrons, they combine them with the ions in solution, and they form atoms. If we look at that in a bit more detail then, at the anode we've got a zinc solid becoming a zinc ion and making 2 electrons. Those electrons are fed up into the circuit. At the cathode we've got copper 2 plus ions taking those electrons down and forming them into copper solid atoms. We need to know a little bit more about what's going on in the electrochemical cell here. And at the top, we've got a high resistance voltmeter. It's really important it's got a high resistance because what we actually want to do is to stop the electrons from flowing round so we can measure how much potential they have to flow. At the bottom here, we have the salt bridge. The salt bridge is really important because it allows the charges to flow from one side to the other. We often put an ionic solution in here, such as potassium chloride, something that won't react with the ions on each side, but it's there to make sure the circuit is complete so the electrons can flow through the voltmeter at the top. So why does this happen then? Well, on the left-hand side here, we've got a more reactive metal which wants to lose electrons more than the metal on the right-hand side. So this metal on the right-hand side, which is a less reactive metal, will want to gain those electrons, or will be made to gain those electrons. And this means that in the cell, we end up with a negative and a positive side. So we have those 2 electrodes with the flow of electrons through the voltmeter at the top. So one of the things we'll have to be able to do is draw out the cell without sort of making a nice sort of pretty drawing at the top like we've got now, but actually a scientific representation for that cell. To do that, we'll create something that looks a little bit like this. So you can see on the left-hand side there, we've got half cell number 1, which is the zinc, becoming the zinc ions. And on the right-hand side there, we've got the copper, it's half cell number 2, and that's copper 2 plus ions becoming copper solid. Now, we show the phase change, that's the change in state, with these solid single lines here. The double lines in the middle are our salt bridge, and that represents the sort of the split between the 2 half cells. And then we put them in order. So we have the oxidation reactions on the left, this is the most reactive element, and we put the reduction reaction on the right, which is our least reactive element. And then we put the elements inside the cell drawing in a specific order. So on the left, we start off with our reduced form of zinc, then we have our oxidized form of zinc. Then we have our oxidized form of copper, and then we have our reduced form of copper. It's really important we remember the order this goes in, and the way that I like to remember it is with ROOR or RAW. Once we've got our drawn cell, we can of course reverse the process and turn it back into 2 half equations. To do this, we need to remember the order which we wrote them in. So we've got our reduced, oxidized, and reduced forms, and we'll start off by looking at the zinc. So the zinc goes from a reduced form to an oxidized form, so we can write it out here as Zn becoming Zn2 plus 2 electrons, because remember, it's been oxidized and oxidation is loss. On the next one then, looking at our copper, we can go from our oxidized form to our reduced form. So this has been reduced, so we can write that out as copper 2 plus 2 electrons makes copper solid, because remember, it's reduction, and reduction is gain. And that's it for the introduction to electrochemical cells today. If you've enjoyed the video and found it useful, please hit the thumbs up below. We've got loads more videos coming out this week, so make sure you subscribe so you don't miss out on anything coming up.